Firebase. This time we're going to cover storage, and it's me, Chris Esplin again. Firebase Storage is fantastic. I cannot stop singing its praises. It is the best, and here's why. You can upload files, all sorts of files, huge files, thumbnails, doesn't matter. You can upload them directly to your client. You can do it without passing those bits through your own server. Now just think about that again. Listen carefully to what I'm saying. You can upload directly from the web to Google, to Firebase Storage, directly from the web client, or an Android or an iOS client, without handling it on your server. I've been doing file uploads from a client through a server up to a storage bucket like AWS or Google Cloud Storage. I've been doing that for years, and it is annoying. It's a pain in the neck to catch and handle these file objects and translate them to buffers and pass them all over the place and manage them correctly. That's really tricky with your metadata. Oh, it's a mess. Okay, so Firebase Storage just does it for you. It handles all that. They've got their own servers running, and they have their own security system in place, and so you can do this really, really easy. So I'm going to do a quick demo on how you do this. The simplest little file upload app I could write. And okay, so to get started, I wrote it quickly with Polymer. Now I've been using Polymer a lot recently because it's just really HTML. It's just HTML, and it looks like HTML, it feels like HTML, acts like HTML. So hopefully this is not too complicated, too messy for you. I really like it a lot. Okay. Polymer. Covered Polymer. Ignore the Polymer. Focus on the code. First, this is your storage tab on the console. You can see I don't have any files yet. I do have some rules. Now these rules, right now, you got to be authenticated. The rules, it's a domain-specific language that looks really intimidating when you first see it, but I promise you it's not. Read the docs. I've got a lesson on quiver.is that covers this right now. Maybe that'll move in the future. We'll see. But these rules are not complicated. Once you've written one, you realize, oh, this is dumb. This is dead simple. You can write these rules. So all paths you can read and write if you're authenticated. I'm saying example uploads folder, allow read, allow write for everybody. So I just opened it up to the world for the sake of this demo because I don't want to fuss with rules authentication. Okay, next. Got my empty bucket. Oh, detail. This is backed by Google Cloud Storage. This goes to a Google Cloud Storage bucket at gs://quiver2.appspot.com. So it's going to the bucket. You can handle it with your Bash client. You can do whatever you want with this bucket and the files that are in the bucket. They're just Google Cloud bucket files. Okay, Google Cloud Storage. This is a front for it. Done. Next. My little app, my Polymer app. It's got a little card here that says choose some files. Now there's an input. Let's inspect this input. There we go. You can see it kind of. I have a really, really, really expanded screen. So there's the input right there. There's my input. Dot value, nothing, dot files, nothing. Oh, there's a file list of length 0. So I'm going to use these file lists. The inputs file list at dot files. So if you don't know DevTools, $0, that refers to whatever is selected in your little drawer up here, which I have minimized. But yeah, that is just the input. Dot files. All right, that gets my file list. So I choose a file. Let's choose, hopefully not too embarrassing a file. Let's go to Dropbox. There we go. Got a beautiful headshot of me. Okay, so you'll see that this now is in the files list. There's a file object. Files list, position 0. It's not an array, so you can't treat it exactly as an array, but it kind of acts like an array. Okay, your file list has a file in it. In this case, it's got a name, Chris Headshot 900 pixels, .jpeg, and it's got some detail on that file. Some fun stuff, the size, the type, whatever. Okay. So now you know everything you need to know about the form. Next, let's go over here to Firebase, or to the browser. I'm initializing my Firebase as per usual. With this, you can actually copy this out of your console. Your Firebase console will give you this block of code. It's the same in every browser that you want to use with this Firebase. So I've got an API key off domain and a storage bucket. You'll see quiver2.appspot.com. That corresponds to your Google Cloud Storage bucket that you're using. Use the one that comes default. Don't try to use another one. I don't even know if it's possible. I fussed with it for a little while. It's not worth it. Use the default. Okay. And the rest is all the Polymer that we're going to ignore. And now the fun stuff. So we need to get you need to get the ref for the storage bucket. In this case, you call firebase.storage to get the storage API, then call .ref on that. You can pass in an empty string if you pass in nothing if you want, and it'll just point you to the top node of the top of your bucket. In this case, I'm gonna put it all under storage-demo. Okay. So all of my this corresponds, and I can do this arbitrarily. Some folder structure. It's just a folder structure in Firebase Storage in your bucket. So I'm going to put everything underneath storage demo. So if I want to delete it all, I just delete the folder. It makes it easier. Okay. Next, what you're going to need is you're going to need a place to save the data related to your files, because you can't just go to your storage, your Firebase.storage, and pull down all that data or all the lists of files and handle them that way. You need to actually store it somewhere. So we're going to store it in the real-time database. That's what makes sense. So firebase.database.ref, and I'm just arbitrarily going to say I'm going to put it under storage demo /uploads. So that'll be my data structure. That's my uploads ref. Okay. Next, uploads metadata. You can pass in a bunch of metadata, and the docs have all the details on what metadata you can and cannot pass in. I typically just pass in cache control as metadata. Max age is 1 year's worth of seconds. So I like to have everything with a sort of a far future, not super far, whatever, a 1 year cache on it. That's my metadata. You can pass another metadata if you want to force it, but I like to stick with cache control as my main. Okay. Next, upload the file. When I click upload right here, it is going to call this upload a file. It's going to pass in the file object. It's going to pass in this guy. The file object itself, that's what is going to get passed in here. Okay? Into upload file. So we have a task, upload task, storage ref. So you'll see it up here, storage ref.child, file.name. You'll notice this file has a name. So Chris Headshot, you need to give it, you need to tell Firebase what to name it. So it's going to be chris-headshot-900pix.jpg. You can name it whatever you want. And then literally I call .put, pass in the file, the file object, the standard out of the box DOM file object, and I pass in the metadata, which you'll see matches here to uploads metadata. That's it. And I get myself an upload task. Okay. Now I've got my task. I want to listen to the task state changes. Now, because this is Polymer and the way Polymer works, you want to, I mean, the way Firebase works too, you kind of want to use promises. So I'm going to return out a promise in my function. You can ignore the promise if you want. All that really matters is this block of code right here. So I take that upload task that I created before by putting the file and optional upload metadata to it. I take that upload task and I call .on state changed, state_changed, and I pass in 3 handlers, up to 3 handlers. These handlers are, first is a progress handler. It receives a snapshot, snap. So I'm going to log out on progress. I'll log out snap.bytes transferred. Oh, slash snap.total bytes. And you can go in and look at all the details to the snap. It's frankly not that exciting beyond the bytes transferred and the total bytes. That's usually what you want so you can handle a progress bar. So I'm just gonna log it. I'm not gonna actually create a progress bar. That would be a tad confusing for this demo, but I'll log it out so you'll get to see the progress events as they go. Next, an error handler. In this case, it just rejects the promise. It logs itself out and rejects the promise that I created above. Not a lot to do with the error handler. Next, fun part, the success handler. This is the last handler. This is the handler, the final handler. So what am I going to do when the upload succeeds? Well, the upload task will get automatically populated with metadata on a snapshot. So upload task.snapshot will now have metadata on it. I can grab that metadata and we'll, you know what, we'll pause at that breakpoint. Let's go to sources. Let's do this. Let's actually fire this thing off. And I'm going to hide my console and minimize this, and let's see if we can put a breakpoint in here. Yeah, the progress and error handlers are really boring, but this guy's fun. Upload. I clicked upload. You'll notice, okay, I'm gonna go over here. You'll see in my console. Can't do two things at once. You see in my console it logged out twice. Just 0. Oh, then it was done. It did it in two blocks. One block. Go back to sources. Okay, metadata. Maybe I can hover over it. Undefined. It won't be undefined for long. There we go. Metadata. It's got a bucket, got cache control, content disposition, all these goodies. Upload task. Doesn't look like anything useful, but it has a snapshot on it. This snapshot. There we go. Snapshot. These functions you can call. It's got metadata, state, total bytes, whatever. I really just use the metadata. Oh, and the download URL. You can definitely use the download URL. So you'll actually see that in a minute. Okay. Now, I like to use the MD5 hash off of this metadata. You see this hash right here. This hash is, of course, this MD5 hash. It's a hash of the file itself, and it will be unique for every file you pass up. So you pass up a slightly different file, the hash is going to be different. So I like to use the hash as my key for the real-time database. So I'm going to save a record on the real-time database with the hash as the key. That way, every time I upload a new file, I get a unique MD5 hash. I could use that as my unique key. Now there's a gotcha with this, and it took me a little while to figure this out. MD5 hashes sometimes have slashes in them. And if you pass a slash in as a key to the real-time database, it will create nesting in the JSON data structure. And you don't want nesting in your data structure for this situation. You'll end up with, like, randomly some of your keys will be nested. Anyway, don't do that. So what I do is I create a key, I replace, using some regex, I replace the slash, the forward slash, with a colon. So if there happens to be, because of the hash of my image or whatever, just happens to have a slash in it, it'll then switch that out for a colon. And that becomes then a valid key that won't nest unnecessarily. Okay, so I've got my key. Next, I'm going to create a file record. This is the record I want to save up to my real-time database. It's going to have a download URL. That comes off of uploadtask.snapshot.download URL. So let's step through this. All right. So the file record, download URL. It's that guy right there. If I hit it, it should be the image. It should be my beautiful mug. There we go. There I am. So that's the download URL. And that's a specific URL. That's specific just to Firebase. It's not a, it's generated by the Firebase Storage API. And it's not a regular Google Cloud Storage URL. So you can create Google Cloud Storage URLs using a server to then use these files. Or you can use cloud storage to make them public and reference them other ways. So this is every time you upload a new version of a file and you overwrite a file at the same name, but with a different file. Every time you overwrite that file, it will create a new download URL, and the old one will be dead. So that's a limitation that I found. If you've got a system where people may be overwriting things, you're going to want to always be getting rid of old download URLs. You don't want the old ones hanging around by accident. Okay, so that was generated by the API at the success of the upload. Next, we got the key, and the key is just, the MD5 hash with any slashes removed. And then I'm just going to pass up a bunch of metadata. The full path, the MD5 hash, and the name. There's a ton of metadata that I don't need, but I'll pass up 3 bits. You can choose what bits of metadata you pass up. Structure this object however you like. This is one way that works for me. Okay. And then all I'm going to do is I'm going to say uploadsref.child, pass in the key, set it to the file record, then resolve. Okay. So let's go over here to a real-time database. Wait for it. I may already have some data under here. No, I don't. All right. So I'm going to let this run. And of course, when it succeeds, I'm going to then either resolve or reject. It passes out a promise as .set always does, and then I will resolve or reject my earlier promise. Fire. There we went. It went. Now, let's see what happened. Example uploads is right here. Oh yeah, it looks like I already had some data under there. So let's just remove this. Delete that. Let's do it again. Upload again. There we go. Okay, there's my headshot. And now my list. What? Oh, storage demo. Ha! Storage demo, uploads. Okay, there's the MD5 hash for the image. There's the download URL, the key, and there's my full path, storage demo, Chris headshot, 900 pics, with the full MD5 hash and the name. And so my Polymer list is just listening and creating a new card for every new node of this collection. And so you just see it right there. Okay. So not a whole lot going on there. Oh, let's remove the file. Want to see how you remove a file? You got to have you got to have the name of the file. In this case, the storage ref is already got the nesting. It's already got the folders built into the ref. Storage demo is already there under storage ref. So it'll always go to the storage demo folder. Then I just have to pass in the file name, which in this case is file.metadata.name, which is file.metadata.name. So you pass in this string right here and call .delete on it. That, of course, returns a promise. You then can catch the success and then delete the record here, or then catch the success from that and pop a toast. And then, of course, any errors. So what happens when I click remove? Click remove, delete it, pop the toast, and we're done. Now I set this up. You'll see this function here, upload file. It takes a file object. I'm using Polymer to actually get all the files, loop through them, and upload them all. So I can do multi-uploads, multiples. And you're going to be able to do that if you put multiple in here on the input. So put multiple on your input, and then I'll call upload file multiple times. And ta-da, maybe? We're going to get to ta-da? We get to ta-da. Look how quick that was. All right. that is Firebase Storage. It is as simple as what you just saw. Yeah, I made it a little fancier with some Polymer, these nice little cards, whatever. But the code is, it's really just creating an upload task, listening to the state change, and saving records of your uploaded files in the real-time database. That's about it. So let me know in the comments if you've got any questions. I will see if I can't post this code to GitHub. And yeah, thanks a lot for listening. See you next time.